Manager at InfoBeans. He excels in finance management, agile project management, and IT service delivery. We are privileged to have him share his insights today. Please join me in welcoming Mr. Nagarajan Kandasamy.
Yes, sir.
Okay, thank you. Thanks for the introduction. Yeah. Okay, so you want to wait for some more minutes, or do you have all the students there? Or?
A few students are coming, sir, but we can continue, sir.
No, since we have 2:30, right? So we have 2 more minutes. So I can wait. Yeah, once. Yeah, we can wait for 2 more minutes. Then I think we can get started. Yeah. Sure.
Yes, sir.
I think I am speaking to Satya Silan, right? Or
Yes, sir. I'm Satya Silan, sir.
oh, okay. Yeah. Thank you. Thanks for coordinating. Yeah. Okay. Yeah, looks like there is an alumni meet in May 11th, I think, in the college. So if possible, I'll try to come. Yeah.
Sure, sir. Yes, sir.
And this digital twin is more like an elective subject to the final year students, or how is that like?
Digital twin is not in our curriculum, sir. If they want, they can pursue as an elective.
Okay. Because like this PLM, right? We had discussed in the past this particular cycle.
And other subjects, these are electives, sir.
Okay. Yeah, I think we'll wait for another minute. I think then I guess we can get started. Yeah. So now we have the students of second year, third year, and final year. Is it or like a mix of all students? Or?
Second year and third year students, sir.
Oh, second and third year students. Okay, good. Yeah. Okay. But how do you prefer? You want to have the session fully in English or a mix of English plus Tamil, or how do you want to have it? Or
Students answer for session of English and Tamil இருக்கட்டுமா இல்ல இங்கிலீஷ்லயே ஹேண்டில் பண்ணுவோம்னு கேக்குறாங்க. Mostly Tamil and English combined prepare பண்றது bilingual.
Okay, sure. Okay.
Sir, I hope we can start.
Yeah, okay. Then sure, we'll get started. Yeah. Hari, video Okay, let me share my screen 1 second. Yeah.
Vignesh, sir.
Hello, Vignesh. எப்படி இருக்கீங்க?
நல்லா இருக்கேன் சார்.
Okay. Good. I think last week where though some busy schedule இருந்துச்சு போல அதனால I thought we'll move it this week. Okay. Sure.
Okay, sir, we can start now, sir.
Okay, yeah, let me start. Introduction கொடுத்தாங்க. Okay, so
okay, sir, we can start now, sir.
Start from beginning, please. ஓகே, ஒரு நிமிஷம் இருங்க. ஐ திங்க் ஸ்க்ரீன் ஷேரில் ஏதோ ஒரு ப்ராப்ளம் இருக்கு. ஒரு நிமிஷம், கிவ் மீ மினிட். இப்போ ஸ்க்ரீன் வருதுங்களா? ஓகே.
Yes, sir. Screen visible இருக்கு sir.
Okay. Then I think we'll get started. So this will be roughly about maybe 45 minute session, and then we can have a question and answer. And in between, for each section, right, I'll give like few or probably few seconds to wait or pause. So that உங்களுக்கு ஏதாவது கொஸ்டின்ஸ் இருந்தது, டவுட் இருந்ததுன்னா அந்த டாப்பிக்கில் இருந்தது, இல்லை நாட் ஓன்லி கொஸ்டின்ஸ், உங்களோட ஓன் எக்ஸ்பீரியன்ஸோ இல்லை உங்களோட கமெண்ட்டு இருந்ததுன்னா we can discuss, and then we'll move on to next subjectனு வச்சுக்கலாம். ஸோ அந்த மாதிரி வச்சுக்கலாம். ஸோ இட்ஸ் நாட் லைக் மோனோலாக், நான் மட்டும் பேசுகிற மாதிரி வச்சுக்கலாம். வில் கீப் இட் மோர் இன்ட்ராக்டிவ் so that the session will be more beneficial to you. Okay. So with that, the digital twin ங்கிறது ஒரு broader terminology னு வச்சுக்கலாம். It can cover a lot of things. But நான் இன்னைக்கு எடுக்கிற செஷன் வந்து கொஞ்சம், since most of the students are from mechanical backgroundனால industrial machineryயோ இல்லை ஒரு மெக்கானிக்கல் கான்டெக்ட்ல தான் டிஜிட்டல் ட்வின்ங்கிற டாபிக் வந்து கவர் பண்ணுறேன் இன்னைக்கு. அண்ட் இட்ஸ் மோர் லைக் இன்ட்ரோடக்ஷன் தான் வச்சுக்கோங்களேன். இட்ஸ் நாட் அ டீடைல்ட் செஷன், இட்ஸ் அ பிரீஃப் இன்ட்ரோடக்ஷன் தான். பட் டிஜிட்டல் ட்வின்ங்கிறது இட் கேன் பி யூஸ்ட் இன் மெனி இண்டஸ்ட்ரீஸ் ஆர் இன் டிஃப்ரெண்ட் கான்டெக்ட். ஸோ ஜஸ்ட் டு லெட் யூ நோ. So this is the agenda or what we are planning to cover in today's session. So to start with the very basics, so digital twin என்ன அதை பற்றி அப்படின்னு சொல்கிறாங்களே, அது என்ன தெரிஞ்சுக்கலாம் அப்படின்னா, வாட் இஸ் டிஜிட்டல் ட்வின்ங்கிறது ஃபர்ஸ்ட்டு. தென் ஏன் அதுக்கு டிஜிட்டல் ட்வின் எதுக்கு தேவைப்படுது, இல்லை எங்கே யூஸ் ஆகுது, ஒய் வி நீட் இட். ஸோ தட் இஸ் செகண்ட் கொஸ்டின். தென் எந்தெந்த டிஃப்ரெண்ட் ஃபீல்ட்ஸ்லையோ இல்லை எந்தெந்த டிஃப்ரெண்ட் இண்டஸ்ட்ரியிலையோ டொமைனில் வந்து டிஜிட்டல் ட்வினோட யூசேஜ் இருக்குது. ஸோ தட்ஸ் மோர் லைக் அப்ளிகேஷன் யூசேஜ். தென் இட்ஸ் மோர் லைக் கன்ஸ்ட்ரக்டிங் ஹவுஸ், ரைட். ஒரு வீடு கட்டும்போது வீடு கட்ட என்னெல்லாம் தேவை, ஸோ அதே மாதிரி டிஜிட்டல் ட்வின் பண்ணணும் அப்படின்னா அதுக்கு என்னென்ன இன்புட்லாம் உங்களுக்கு வேணும், அதை வச்சுட்டு ஹவு டு யூ பில்ட் அ ட்வின் ஆர் டிஜிட்டல் ட்வின். ஸோ தட் இஸ் ஆன் த கன்ஸ்ட்ரக்ஷன் பார்ட். தென் வில் கவர் ஃபியூ ரியல் வேர்ல்டு யூஸ் கேசஸ். ஸோ நம்ம வந்து வெறும் தியரிட்டிக்கலாக மட்டும் பேசாமல் ரியலாக ஒரு கம்பெனிஸ் வந்து சில கம்பெனிஸ் ரைட் நவ் தே ஆர் யூசிங் த டிஜிட்டல் ட்வின் டு கெட் லாட் ஆஃப் பெனிஃபிட்ஸ். ஸோ எந்தெந்த கம்பெனிஸு ஸோ என்ன பண்ணுறாங்க அப்படிங்கிறத பற்றி ஒரு ரியல் வேர்ல்டு யூஸ் கேஸ் பார்க்கலாம்னு வச்சுக்கோங்களேன். தென் வந்து ஒரு 2 minutes ஒரு ஷார்ட் வீடியோ இருக்குது யூடியூப்பில். இது ஜிங்கிற ஜெனரல் எலக்ட்ரிக் கம்பெனி, அவங்களோட டிஜிட்டல் ட்வின் வந்து நெட்வொர்க்கிங், எலக்ட்ரிக்கல் டிரான்ஸ்மிஷன் லைனில் உள்ள நெட்வொர்க்கிங் பற்றி, அதை பற்றி ஒரு 2 minutes வீடியோ இருக்குது, பார்க்கலாம். தென் வந்து நான் வந்து ஒரு நாட் ரீசெண்ட்லி ஒரு மேபி 2016-17 அந்த டைமில் வந்து டிஜிட்டல் ட்வின் ரொம்ப ஏர்லி ஸ்டேஜில் இருக்கும்போது வி டிட் அ ப்ரூஃப் ஆஃப் கான்செப்ட். ஒரு ரியல் இம்ப்ளிமெண்டேஷன் கிடையாது, பட் ஒரு கான்செப்ட் ஐடியா வந்து டிஜிட்டல் ட்வினில் பண்ணணும் அப்படின்னா ஹவு டு வி அப்ரோச் இட் அப்படிங்கிறதுல ஐ வாஸ் இன்வால்வ் ஃபார் ஃபியூ மந்த்ஸ் இன் அ கேஸ் டர்பைன். ஸோ அதை பற்றி ஐ தாட் ஆஃப் கவரிங் இட். தென் வீல் ஹாவ் அ கொஸ்டின் அண்ட் ஆன்சர் செஷன். ஸோ திஸ் இஸ் த ஓவரால் ஸ்ட்ரக்சர் ஆஃப் டுடேஸ் செஷன். So any questions, anything on this one before I move on to next one?
No, sir, not it, sir.
Oh, yeah. No questions, I will move on. ஏன்னா ஸ்லைட் மோட் இருக்கிறனால நீங்கள் ஏதாவது கொஸ்டின்ஸ் ரைஸ் பண்ண தெரியாது. ஸோ இன்கேஸ் கொஸ்டின் தான் சொல்லுங்கள், தென் ஐ கேன் ஸ்டாப் இட். ஓகே,
Sure, sir.
Okay. So keep it more interactive. So that is the only request from my side. And in case mobile phone, either keep it in silent or switch off. Either option is fine. Yeah. Okay. So first of all, we'll start with the small definition. So what is a digital twin? It's more like a virtual representation, right? So it is a representation. Maybe think like a drawing, or think like a picture, or think like a model. So it is a virtual representation of a physical object. Physical object can be anything. Maybe in my case, I'm going to cover a gas turbine, or it could be an automobile, a car, or an aircraft flight, or any physical object, or a system. It's not only a single component. Maybe the electrical transmission line or electrical system I'm going to cover. It is a collection of different items. So maybe there is an electrical generation system, like a generator, and there is a transmission line, and there is a distribution line. Put together everything, form a system. So it can be a virtual system or process, like consider a manufacturing process or assembly line or a shop floor. There you are producing a component by following various manufacturing process, or even the chemical industries. So there's a chemical process which will produce certain component or as an output. So it can be used for an object or for a system, or even for any processes. And the key here is it try to simulate or try to mimic the real world behavior. So that is a simulation is one of the key component of a digital twin. It simulates the real world performance and behavior. So that's a brief definition of what is a digital twin. And how do you make a digital twin, right? Because this is something you have to create it. So how do you make it? So you have to integrate a lot of data, and which comes from different sources. So when I say different sources, maybe it could be your CAD model, or it could be your FEA model, or CFM or CFD model, or it could be some manufacturing data. Maybe it could be a data from the service or from the field. If let's say there's automobile or car, and the field could be maybe the place where you go to a mechanic, or the place where you go to the car service. So he also can send certain data, and this data can be captured in the form of sensors or like IoT devices, Internet of Things devices, and other digital inputs. So put together, you're getting the information from different places, and then feeding to the twin. And it is not a static one, meaning let's say you create a CAD model as a mechanical engineer. So you create a CAD model. It is pretty much static unless you keep changing it. But in the case of a digital twin, it's not a static model. It's a dynamic model, meaning it keeps changing with the new inputs or change in the condition and things like that. And by which it mirrors the physical counterpart. Maybe an easy example could be, take the case of an automobile or car. Let's say you buy a car in this current year, 2025. It's a new car. It is running in a good performance. But after 5 years, the performance slowly degrade. Maybe the speed may not be that much, and the brake may have a problem, and the clutch will have a challenge, transmission will have a problem. So the model is also should be dynamic to capture the current condition of the part. So that is the other aspect of the digital twin. It's not static, it's a dynamic. Yeah, so that is a very basic, simple definition of a digital twin. It's a very generic definition. It can be used in any product or any component, but just to get an idea. So any questions, because this is a foundation or basic of understanding what is a digital twin. If you have any questions, I think you can ask now. I'll try to answer to the best of my ability, whatever I am aware of it. Yeah. So anybody has questions? Because for the subsequent slides.
No, sir.
Okay. Sure. Okay, so this is a very simple picture of a gas turbine. So just to give an idea, right? So on the one you see on the left-hand side, consider more like a real world or the actual gas turbine. And the one you see on the right-hand side is more like the imaginary or the virtual representation. So maybe as mechanical engineers immediately think it's a CAD model. Yes, CAD model is one of the basic or foundation of the digital twin, yes. But it is much more than the CAD model. It can feed or it can capture a lot of different data, and which can be fed into this model. So which we'll cover in the coming slides. But this just a put to get an idea about what could be a digital representation of a physical product. Okay. So the next question is, now so far we covered what is digital twin. Now we'll talk about why it is needed, because there has to be some purpose or a meaning, right? Why it's needed. So it has a lot of points, but probably I cover about 5 to 6 points here. So first one is to make a better decision. So when I say better decisions, right? So whenever you make some decisions, you need data, and the data could be the real time, the current data. So it says real time insights and data analysis, right? So maybe to give an example, when I say make a decision making, right? I think that's covered in the next point as well, predictive maintenance. Again, we'll go back to the same example of automobile or a car. When you're doing a repair or a maintenance of a car, if you have the proper condition of your tire or proper condition of your transmission system or brakes or any component or engine, if you have the right data, maybe in the last 5 years, my vehicle has gone for service for 3 times, and 2 times it went for the regular maintenance. 1 time there was a breakdown happened in my car. If you have such proper data, then making the decision, right? So maybe for the next 4 to 5 years, my car will not have any major problem. And after that, probably gradually it will have continuously or repeatedly it will have problems. So the digital twin is required to make a better decision making. And how it helps you to make a better decision making? By providing, you feed the system with the right data, then it provides the decision making. Yeah, the second point is predictive maintenance, also more or less similar to that. So when you say maintenance, right, there are different type of maintenance. One is a periodic maintenance. I'll take my car for every 6 months or every 1 year to the mechanic shop or the service center as a regular maintenance. But the predictive maintenance is more like data driven. Let's say if it's a single driver and you are only taking the vehicle to the office, like, let's say 10 kilometers per day or 20 kilometers per day, and you're keeping the vehicle very neat and very nice, you are not racing at the optimal speed, then maybe your car even may not need a maintenance, let's say for more than 12 months. But someone taking the car for a longer distance, let's say 500 kilometers, 600 kilometers, and going at a very high speed and doing a rash driving, then probably the car might need, even after 3 to 6 months, you may need a maintenance. So this maintenance data is based on how you are running the vehicle. So the predictive maintenance, right? So to enable that, you have the digital twin, which will help you. And the other aspects are like the operational efficiency and improved product development. Maybe for the operational efficiency, I can explain with an example. Consider more like a product line. It could be a car assembly line or a bike or any component or any product for that matter. You have an assembly line. In the assembly line, you can simulate with various, you can call it as what if scenarios. What if I make a Maruti 800 car in my assembly line? What if I book Maruti different product of Maruti variation, different type of a car, let's say. So then you would make slightly changes in your assembly line to cater to the different type of products you're going to send from your shop floor, or not shop floor, from your factory. So these are different scenarios, so which you would accordingly keep your assembly lines and keep your resources and keep your equipments accordingly. So this is instead of doing it manually, you do it in the system and try to simulate it upfront and see, am I having an operational efficiency in terms of resources? Am I using all the technicians or the shop floor resources and things like that? So where operational efficiency would be achieved by digital twin. And the last point is more of improved product development. So this, as a mechanical engineers, probably we spoke about this product design and development or the PLM topic in the previous session. So consider more like you have a CAD model, you have FEA model. So before actually manufacturing the product, you do the testing or simulation in the virtual system and take the results of FEA model or take the results of that CFD model or the flow model, fluid dynamics flow. Then accordingly you go to the shop floor or manufacture product. So definitely it helps in the product development. So these are some of the benefits of why you need a digital twin. And coming to the next slide. So this is more like customization, personalization. Now, probably you might have noticed with IoT or industrial systems 4.0 or the current one, people no longer need the mass product. Meaning earlier, if you are getting a certain product, let's say bike for example, or a car for example, there are thousands or 10,000s of car of same size produced, and everybody is using the very same car. Even your household appliances, maybe a mobile phone or anything for that matter. But these days, the customers or consumers are more choosy, and they want certain products which is more customized or specific to their individual preferences or taste. So this is the common trend happening across multiple industries. And in this case, the customization more in the context of the healthcare industry. Let's say if there's a patient and who has to be treated for certain diseases. So instead of directly giving the prescription, or especially the chronic disease, a patient who is there for a longer years, then they create a model for that and feed all their health records for the past 10 years or 20 years. Then simulated it for this patient. If I give this much tablets, or this is a medical follow-up, then this patient can prolong for a certain period. So that also happening in the medical industry. Companies like Philips, companies like G Healthcare. So these companies are started working on the digital twins for these healthcare industries. And the other one is collaboration communication. When multiple parties, maybe with your vendors or with your customers, and when you want to work together, having a common digital model, it could be a CAD model or anything similar, and exchange that across the network, or put it in a cloud and everybody is accessing it. So this would be very easy for all the related parties or the related team to work together. So where the twin would be very beneficial or helpful. And the last point is more like the lifecycle management, which I think we touched upon in the PLM, right? So the product is not about design the product and release the product to market. It's much more than that. After you release the product to the market, this has a life of 10 years or 20 years or 30 years, depending upon the life of the product. So you have to consider all the life cycle aspect, meaning how long this product going to be there in the market and what kind of operational issues this will face. So all those information should be fed back into the system, like a feedback system. Then it will be a complete life cycle of the product. So there the PLM helps. Similarly, the digital twin, right, would be very beneficial. Yeah, for this topic, I am going to touch upon in my last example how the digital twin is going to be beneficial in the entire life cycle of product. So these are the reasons why you need a digital twin, some of the points. So any questions, or anybody wants to share some thoughts or their understanding, or I'll pause for a few seconds here. Somebody wants to mention, yeah, or based on your industrial visit, or based on what's your experience, if you want to share something, yeah, please feel to share. Okay, yeah, if no questions, I can move on to, but yeah, please feel free to stop me if you have want to share something or you have some questions. Yeah. Yeah, moving on to next one. So it's more like constructing a house, right? When you want to construct a house, you need the different materials. You need brick, you need sand, you need cement, etc. All the different components. Then only you'll be able to construct a house. And there is a process how you construct a house. You have electric line, you have plumbing line, etc. So similarly, when you want to construct a digital twin, right? It is a systematic approach. So you have to construct with a lot of data. So instead of physical product, here we are using data, which is needed to construct. Then the models. The models here we are referring to not only the CAD model, but also the mathematical models and other models outside typical mechanical engineers. There are other models which would be needed for the digital twin. So when you're constructing a digital twin, the first and foremost thing is you define the objective. What for you want to construct the model. So you want to construct for a purpose, right? What is the purpose you want to construct the model? So is it to want to have an optimal energy usage in your product, or you want to do a predictive maintenance? So what is your objective of constructing a model? The second part is, or the main part is the data collection. So the data collection is typically through the different sensors or the IoT devices. You want to continuously get the data from the physical product. Let's say the automobile or a car, or even the gas turbine, which I'm going to cover later. So there's a physical product, and you get the data through the sensors. So what kind of parameters you are going to collect it? It could be typically the temperature, or the pressure, or the vibration, and the different operational metrics, which will collect it using sensors. And the next aspect is the historical data gathering, right? So you mainly collect the past performance and the maintenance of the vehicle, maintenance logs and things like that, and the environment conditions. Maybe are you running your car in a desert? Are you running your car in a very snow place? And what is the running condition of the, or what is the road condition? Are you running in a highway or running in a maybe small roads, things like that. So all these informations are required to build a proper model. Yeah, the last point is the mechanical aspect of it. So I'm not going to speak much. You as mechanical engineers will be more familiar. The CAD models and the CFD and FEA models. So these are the key components to construct a digital twin. And the other aspects of construction of digital twin is data integration. So now you have a data, and how do you want to handle or manage the data? So at least here, the second part, the data management systems, at least I can share some of my experience. So I work for the Lace chips, right? It's from the Pepsi product, the Lace, Frito-Lace, the Lace chips. So in the manufacturing plant, they send a lot of data from the shop floor in terms of the different segment of the Lace chip manufacture. It could be the fryer where you fry the chips, or there's a weighing machine, and there's a place where you put all the seasoning like salt and other seasoning and flavors, and then packaging and send it. So it sends ton of data on a daily basis. In an 8-hour shift, it sends a lot of data, and the IT system should handle the data, and you should have a mechanism to store the data like a database or a server to handle the data. And later you need to analyze the data, because just having data alone is not going to be helpful. You want to analyze the data. So data management system should be a critical component when you have a proper digital twin. And these days we are talking about streaming, right? Like a video streaming. So the data, the type of data can be a variety of data. It's a digital data like zeros and ones or binaries, or it could be analog data, or it could be from the different sources, right? So you have a continuous feed of data, so you should be able to capture it. And the next one is predictive analytics. So this may be more in the form of algorithms, right? So which will help you to predict the future performance based on the current state of the system. And this is where the machine learning comes into picture, or artificial intelligence comes into picture. So the predictive analytics as well, I think in the gas turbine area, which I had some exposure experience. So continuously feeding, let's say I have a proper data for the last 5 years. Then I can confidently say, based on these conditions, I have, based on the last 5-year data point, I can confidently predict that my turbine will run for the next 2 years without much issues. After that, there could be some planned maintenance I should go for. And this can be done with the help of these different mathematical models or algorithms. So which is pretty much which is same as the machine learning. And the last one is more of validation and calibration. So this now let's say you have constructed a model or a digital twin, but how do you ensure that that model is accurate? Because model is created based on certain assumptions, certain input data, but you want to validate the model to make sure it's working fine, right? So that is more like the validation part of the model. So how do you validate? Maybe let's say take again the example of an automobile. Let's say with the data, let's say a car 5 years old after you take from the showroom, and let's assume you have a digital twin for your car, and as per the car's data or the digital twins data, it says you don't need maintenance for the next 6 months. But after 3 months, you started having a problem, or you're having some issue. That means the digital twin is not very perfect or accurate. Maybe it's time to do a course correction, or time to fine tune the model. So that's more like a model validation. And it's not a one-time task. It is a continuous improvement. You have to keep on refining the model further, so that it will be more matured or more stable model. So this is the different topics or points about how you want to build a digital twin, like building your house, and how do you want to validate the model so that it is accurate, or it may not be always perfect, but that's at least near perfect. Okay, so any questions on this part? Anyone, or even if you have some thoughts or inputs, yeah, please feel free to share. Yeah, I'll pause here for a minute. If somebody wants to go, any questions? Or is it afternoon? So sleepy afternoon, or
Sir?
yeah.
So you said that using ML and AI, the data are taken and it is taken in the digital twin.
Yeah. Yes. Yeah.
So how do you validate it? Like check whether the given data is right or wrong.
Correct. So that is the last part we were discussing. So the calibration or fine tuning, right? So you are getting a data from real world system and using sensors and things, and you are feed into the model, which let's say the model is created using artificial intelligence or machine learning. But this model itself is not it's not really perfect, right? So how do you validate it? Again, you go back to the real world scenario and get the data and then feed it back. It's like a continuous loop. So the artificial intelligence model itself will not help you. Rather, you have to go for the manual or the physical validation, and then do the feedback to the system back. Then only you will be able to improve the model. Yeah. Even take the case of maybe your ChatGPT, right, or Gen AI, all the LLM they call are large language models, right? ChatGPT as an example. So whatever the models they constructed, it was not perfect on the day one, but as more and more users are using the model and giving a feedback, then it's getting smarter. So even if you go and give a very generic query today, it'll give some answer. But if you provide more context, then it'll give a better answer, right? So with this, more and more user inputs help the large language models like ChatGPT to improve the quality of output. So similarly, the models, let's say we're creating using some algorithm, we need to keep on feeding the algorithm with the feedback. Then only the model will be further fine-tuned or improved. Yeah. It may not be perfect, and it will go for at least few iterations, I would say. Yeah.
Thank you.
Okay. Okay. Next, for the couple of slides, we'll talk about where this digital twin will be used, right? The application, the different industries. So maybe the underlying purpose more or less common or similar, but the industries are different. So the few examples I put here is one is the aircraft monitoring. So here in the airline industry, right, you are to continuously monitor the health of the airlines or the aircrafts in a real time. So with different sensors in the system, maybe at the jet engine or maybe at the different components in the system, so the pilot gets real-time data, right? So the data itself can be fed into a digital twin model. Then it will give predict, okay, maybe after 10,000 miles of hours or maybe 20,000 miles of flying hours, you have to stop the flight in the ground and do some repair or maintenance before for the next takeoff. So those kind of monitoring, you'll be able to do it with the help of the digital twin. There's one use case or scenario where you can do it. And similarly, the design validations. So this like consider like Boeing or consider like Airbus, right? The companies who are manufacturing the aircraft, so they can definitely use this model at the time of design and manufacturing. The same use case or similar use case in automotive, which we kind of touched upon earlier, the vehicle performance. So it can simulate your vehicle's behavior and it can tell you when likely it can fail or when you should go for maintenance. And similarly, the fleet management. So here at least I have one scenario where I have some exposure. Right now we work for a logistics company and where they are engaging different contractors to shipping the parcels. Some contractors or some companies having tens or even some bigger companies have hundreds of their vehicles or the trucks, and they manage the entire fleet of the trucks. So at any point in time, they need, let's say I have 100 trucks, then I need to know out of 100, at least 80 to 90 trucks should be in a good condition so that it won't fail often. And some trucks I will keep on sending it for maintenance often so that when it is back, it will come to the main fleet. So I need to have some data to check the condition of my vehicles and smoothly operating my entire fleet. So there, this model will help. The other scenario would be on the electrical domain or electrical industry. The first one is the grid energy and the grid management. So consider like TNEB, right, or Tamil Nadu Electricity Board as an example. So in summer we have more energy or more demand, and especially now we are already in March, maybe in April, May timeframe, right? With high temperature, you will have more air conditioning and more demand for energy. So the TNEB should monitor the energy demands, how many megawatts or how many gigawatts of energy people are consuming, and what is the source of production of energy, right? Like the hydel turbines or the wind turbines or some of the gas turbines and the thermal with the coal, right? So the different source of electricity, how do you balance the demand? So this can be fed into a model, and that can provide some directions or some recommendations. So this we are going to talk about in the 2-minute video for the GE or General Electric example. And the last one is the renewable energy, like solars and wind turbines, right? So they can simulate the real world model, especially the wind turbines. Yeah, I can simulate the model, and which can give a prediction of the performance. Is it 100% or 80%, 90%? It can give some sort of indication. So these are some of the industries or places like aviation sector, automotive, energy sector, where the digital twin can be used. Yeah, there are much more use cases, but I think these are some of the common scenarios which we can relate with. And I'm covering 2 more here. So one is on the smart cities, right? So outside the traditional design, nowadays there are smart cities concept. I believe Singapore already started using this one. So like that, different cities for their urban planning, they create this virtual model in terms of their infrastructure, in terms of their traffic, and what the different resources like water and sewage management and etc. So they put everything. They have a lot of data, but when they feed into a model, right, they have a better idea about how do you do the urban planning. And the other one is the building management. So these days, I think for building management, you have different certifications like LEED or certain certifications, which will give that certain third-party companies will certify your building for optimal energy consumptions, less utilization of power, right? Or taking advantage of solar or solar panels and things like that. So there also you can utilize the digital twins. And on the supply chain and logistics front, yeah, definitely on the transportation side, you can optimize your vehicles, and you can virtually represent your flow of the shipment, then which will help you in the model. Yeah. So this is some of the use cases which digital twin can be used. So if you can think of any other use case, yeah, please share your thoughts. But I think this is only a list of few use cases or scenarios where this can be used or already used. But definitely you can think of a lot more cases. Yeah. Yeah, just to extend. So these are the real world use cases, meaning these are like companies who are already using digital twin in their day-to-day operations. So starting with Siemens, as you might be knowing it already, it is one of the market leader in most of the energy equipments and also the engineering related software systems. And they are using this in their manufacturing operations or shop floor called smart manufacturing. So that means they are not only selling the software, but also they are implementing the digital twin in their own factory to prove that it is really helping in improving their efficiency. Yeah, Boeing as key player or the main player in the aviation sector. Yeah, they are using a digital twin for their fleet management because Boeing supply the aircraft to different airlines. Let's say like Air India, United Airlines, or any airlines for that matter. But after selling the aircrafts, they need maintenance or they need service contracts. So Boeing needs to have all the data of the airline they sold or the aircraft they sold and what's the health and performance of those airlines. So they continuously monitor the data which is used for their fleet management. So it's mainly for the predictive maintenance. And two more examples. Yeah, one is on the wind energy side, Vestas, which probably you might have heard or you're familiar with the name, who is one of the market leader in the wind sector. Yeah, this is for optimizing the wind performance of the wind turbines. So they are simulating the physical wind model. The physical wind turbine model in a virtual way. So since the system already has a lot of sensors to collect the data, it's a lot more easier to predict or get an output from the digital twin. Yeah, similarly in the logistics domain, yes, DHL, one of the leader in the logistics domain, they already started using this model for better of their supply chain operations. So it's virtually representing your warehouse where you get a lot of shipments on one side, and on the other side you are sending a lot of shipments to different places, maybe different cities or different countries. So you are able to simulate the model using this virtual representation. Yeah. So DHL is in the logistics sector, Vestas on the wind domain, and Boeing's in the aviation sector, Siemens in the manufacturing and the energy sector. So different sectors, they're already using it. So that means it's no longer a theory or a concept. It's more of a real world implementation, and people are getting benefited, or companies are getting benefited. Okay, so any questions so far? If not, we'll take a quick 2-minute video, then we'll come to the last section. Yeah. Any questions before that?
Sir, actually, I have some question in this topic.
Yeah, sure. Please go ahead. Yeah.
Actually,
Yeah.
I have attended a workshop on digital technology in a company. I mean, in a NIT Tiruchi workshop. So
okay.
there is a person. I mean, the workshop is conducted by the Brilio company. It's a startup company where some of the few internship students have made some make some innovations like the 5G coverage data, which has
5G.
been implemented in digital twin technology, sir.
5G.
So like that, in how it is related to mechanical industries, because in when we go to the EC based, they are just working for implementing the towers. So where we can able to implement the towers so that we can able to cover the 100% of coverage. So like that, in mechanical industry, how they are using this digital technology, sir.
Okay, so it is used in multiple places, but what I can say is based on my own experience or my own understanding, right? I have the next slide for the gas turbine, where the gas turbine, the remote monitoring and diagnostics, or RMND, we shortly call this. So in the gas turbine, during the service life, right? Once you design a gas turbine, you manufacture it, you send it to your customers. In the customer's factory or the customer's plant, you want to predict the maintenance. So how my gas turbine will run for the next 20 years, when it will fail or when it will work fine, right? So I want to predict and then do the maintenance schedule accordingly. So this is one of the use case in the mechanical industry, which I was involved in some of the proof of concept few years earlier. So that's the one I'm going to touch upon. Yeah, but yeah, this is one small case, one use case only. But in mechanical industry, there are several use cases. But yeah, this one we can cover it after that video. Yeah. But yeah, thanks for the question. Yeah.
Sir, and another question.
Yeah.
So actually, we have gone to the workshop. So there is a small startup company only, sir. So they are just integrating like manufacturing enterprises, etc. It's based on a consultancy based one, by one and only using the digital twin technology. So like that, can you suggest some any companies which is working purely based on the digital twin technology, sir?
Okay, there are several companies who are using it. Yeah, Siemens I mentioned earlier, right? So this is one company already using their products. But if you're asking a startup or maybe a small scale, I'm not sure. But definitely on the bigger scale, yeah, Siemens is definitely one good company. And even the other companies like Dassault System, where you have this what is the software for the CAD model, right? I think Dassault now has a CATIA, I believe, and Innovia has the PLM system. And yeah, yes, definitely Siemens, one company I could immediately suggest, and the other one is GE or General Electric, GE. That's the other company I could think of who are already using this. And the other one is with a Pro Engineer Creo, right? Creo or Pro Engineer. That parametric solutions, the parametric PTC. PTC is the other company. These are the core mechanical or mechanical related companies who are already using in digital twin. Yeah, but this is only a small list. There is plenty of companies who might be using it, but this is only a small list I can think of. Yeah.
Yeah, okay, sir.
Okay. Yeah. Thank you. Any other questions, sir?
Sir, I mean, you have already said that the decision making will be done by this digital twin technology. So, how it is going to impact human decision making in the industry, sir?
Okay. So when you say human, okay. So to answer your question, right? If you go to ChatGPT as an example, when you're querying it, they'll put a small fine print at the bottom of it saying that this is not a perfect answer. Still, you have to review this with some experts, or you have to take your own decisions. Don't just rely upon the ChatGPT. That's a small description or a terms and conditions applied at the bottom of it. So something similar. All this output or the decision making, right, comes from the systems. Initially, definitely we cannot take it as granted, meaning it may not be 100% perfect, because the quality of output or the decision making correctness, or how the confidence level, I would say, or the correctness is based on the quality of input and the condition of the model. So it goes for a continuous refinement, and maybe at some point in time it will reach its optimal or a better performance, but it can never be 100%, I would say. Yeah. So the decision making, still a human decision making might be required, but it'd be a lot more easier with the help of a machine. Yeah.
Sir, another question.
Yeah.
Whether this digital twin technology is already available in industry 4.0 or will it be coming to the industry 5.0, etc.?
No, I think this is there for quite some time, because when I mentioned I was involved in 2017 or 18 as a proof of concept. But right now, I think a lot of these products are matured. So I would say the 4.0 itself, right? So or the current generation itself, there are products or real world usage. So I would say it's already there. So it may improve further, no doubt, with a lot of advancement are happening in the machine learning or AI. But as such, it's already there. Yes. Yeah.
Thank you, sir.
Okay. Yeah. So now we'll switch on to 2 minutes YouTube video. Then we'll come back for the last one. Then we can close the session. Yeah. Let me know once you're able to see the video. Not sure you're seeing the slide or video. Let me stop presenting and present it again to see. I think you are able to see the YouTube, right?
Yes, sir.
Okay, it is for a company called GE or General Electric, and this digital twin is more on the electrical transmission line. Yeah.
Electricity industry is entering an unprecedented time of disruption and change. Decarbonization is driving the adoption of decentralized renewable energy, which in turn brings complexity to the grid with a multidirectional flow of energy and an increasing number of connected devices. Utilities are looking to digitalization to increase innovation, reduce cost, and manage risk. Traditionally, electric utilities have operated in siloed organizations where each department, for example network design, has a separate and specific view of the grid. In order to meet the challenges of the modern grid, utilities need one comprehensive view. This approach reduces inefficient business processes and eliminates manual data sharing. And as a result, utilities can harness the benefits of digitalization and provide more innovative services. The Network Digital Twin from GE provides a comprehensive view of the grid combining GIS, EMS, and ADMS, all powerfully shared across the utility. The Network Digital Twin is software that connects physical systems on the grid with the capabilities of the digital world. It is the digitized version of the living organism that the modern grid has become. Network Digital Twin accumulates data over time about the structure and location of assets, their operation, and the environment in which they operate. On top of that asset data, valuable intelligence is developed using analytics, physics, and continuous machine learning. Past and present asset performance and operation are stored as part of the digital twin and can be used to predict future outcomes. The Network Digital Twin builds on the breadth and depth of GE Power's software solutions. And thanks to the power of Predix, GE's industrial internet platform, critical business insights and intelligence can be used with edge devices, on-premise, and in the cloud. With the Network Digital Twin, multiple data sources can be fully leveraged to simulate and predict how the grid can be optimized. This puts an end to hunches and guesswork. Field crews can be dispatched to the right location with the right information in order to rapidly fix what's broken and optimize network reliability. Asset maintenance moves from reactive to predictive. And utilities gain a forward-looking, fact-based view into where they need to make capital investments in order to remain resilient, increase efficiency, and provide better customer service. Network Digital Twin from GE breaks through organizational data silos to digitally transform your grid.
Okay, it is 2 minutes video, so not sure how was the audio part of it. Was audio is clear, audible or?
Yes, sir, it was audible, sir.
Oh, okay. Yeah. This is just to give an idea about, how GE is having a network twin. Yeah. Okay, so now the last slide is more of what my personal or my own exposure to the digital twin. I'll cover that. Then I think we can close the session or complete the session. Yeah. Yeah, now we are back to the slide mode. You are able to see my slide, right? Yeah. Okay, so the last slide is for the gas turbine. RMND stands for Remote Monitoring and Diagnostics. So this is not a real product. It's more like a concept or a proof of concept. That's what I was involved some time back. So this is for a company in US or North America, and who are exporting the gas turbines, both within US as well as to different countries. And typically you consider a gas turbine life at least 20 years as the estimated life. And in this case, they have more than 300 plus gas turbines, which are shipped or sent to the different location or different customers where it is installed. And for the gas turbines, right? Just to give you an idea, the companies are making money more in the service than in the product itself. You sell a product, you get some revenue or profit, but you are doing the service for the same customer, let's say for the next 20 years, then you get more revenue on the service contract. So more companies are focusing on the service part of it, because I sold the product. Now let me go to the customer and take the service part of it so that I'll get more revenue. So that's the background of this project. And what they're trying to achieve or what is the use case for digital twin is you want to continuously monitor the gas turbine and for both planned and predictive maintenance, right? Since you're already giving your equipment or not your equipment, you're selling your equipment to customer, and you also send your control systems, because for gas turbines you need a proper monitoring and control. So you are selling the control system as well. So what this customer does is they have one common, they call it as a remote command center in US, which is connected to all their gas turbines through the networks. So they are able to get the feed of their sold gas turbines through the network. So the real-time feedback of the different metrics. So it could be what temperature the gas turbine blades are, and what is the pressure, and if there are any vibration in the foundation, for example, or other operational metrics like what is the power it produces and things like that. So all these informations are coming to their central or their main command center in US through the network. So what they decided was, since I'm already connected to all my gas turbines across the world or most of the places, I'm getting the feed. So I can use this information to create a digital twin. So I can create a virtual representation of each. Let's say I have 300 turbines. I can create a 300 imaginary or virtual representations. Assume in a simple way, assume like a small gas turbines, and in the CAD model, and you keep feeding the model with a lot of data about turbines. When I say a lot of data, let's say one turbine failed in the year 1, so then you send the data to that. Maybe a different turbine failed in the year 3, then you send the data there. So like that, you keep on sending the data after the turbine is installed. Then you are capturing the information to the digital twin. And so it helps in two places. One is it helps you to predict. So when is going to be my next maintenance schedule? It's going to tell you. So for this turbine, maybe you plan for the maintenance in the next 6 months. For this particular turbine, you are running smoothly and very quietly. So maybe you don't do the maintenance for 6 months. Maybe you can wait for another 6 more months. Maybe after 12 months, you can do it. And things like that, you can provide a predictive maintenance. And in the other place, it was helpful for the customer was for the service contract, they quote a value. They provide this much cost you need to pay me for the service contract. And how do you put the cost based on the health of the turbine? Maybe take the case of a bike or a car, right? If somebody is maintaining the bike properly, the possibility for the mechanic, right? Let's say you are going for a AMC or annual contract with a mechanic. If your bike is in a good condition, probably if you let's say 2,000 rupees as an example, just to say that, then the mechanic will not have much expenses since you are maintaining the vehicle good, and maybe he'll get more profit. Maybe somebody is not maintaining the vehicle properly, but still go for the same 2,000 rupees as the AMC. Then in that case, maybe the mechanic has to spend a lot of money because he has a contract with you and he agreed that I'll do the service for certain times. So whatever given the contract, maybe he has to spend more money. In turn, his profit will come down, for example. So similarly, in the case of gas turbine, so the customers will provide a quote based on the health of the turbine. If the turbine is good, maybe they will go for a lower cost. But if the turbine is really not good, right, then they have to consider that and increase a higher quote so that they are not impacted or their profit is not impacted. So this is one scenario where we were started doing a POC or proof of concept. So mainly for the predictive maintenance or probably give an optimal quote value for your contract. So this is something I was involved, so I thought I can mention it here. So was it relevant to some? I think somebody asked the question. Was it relevant to your question or?
Hi sir, I am Sanjay from second year mechanical.
உட்காந்து கேளுங்க. ஓகே. ஓகே, sure.
Sir, how was the digital twinning secured from data privacy, sir? Data privacy வந்து எப்படி digital twinning ஓட இது பண்றது?
Okay, so data privacy is a very என்ன சொல்றது, ஒரு காமன் சப்ஜெக்ட் தான், ஜெனரிக் சப்ஜெக்ட் தான். ஸோ டிஜிட்டல் ட்வின் மாதிரி லைக் சைபர் செக்யூரிட்டியோ இல்லை ஹவு டு யூ ப்ரொடெக்ட் யுவர் டேட்டா இருக்கு இல்லையா? ஸோ அந்த பாயிண்ட் ஆஃப் வியூவில் வந்து the general data protection mechanism will apply to digital twin as well னு வச்சுக்கோங்களேன். ஸோ ஜென்ரல் ப்ரொடெக்ஷன் எப்படி சொல்லுவாங்க, அந்த டேட்டா ப்ரொடெக்ஷன் 3 ஆஸ்பெக்ட் சொல்லுவாங்க. டேட்டா அட் ரெஸ்ட் சொல்லுவாங்க, அப்புறம் டேட்டா இன் டிரான்ஸ்மிஷன் சொல்லுவாங்க, அண்ட் டேட்டா இன் யூஸ்ன்னு சொல்லுவாங்க. ஸோ டேட்டா அட் ரெஸ்ட்னா இப்போ நீங்கள் உங்களோட கம்ப்யூட்டர்லையோ இல்லை உங்களோட சர்வர்லையோ ஸ்டோர் பண்ணிக்கிங்க. ஸோ ஹவு டு என்கிரிப்ட் த டேட்டா ஸோ தட் நோபடி எல்ஸ் ஆர் ஹவு டு யூ கண்ட்ரோல் த ஆக்சஸ். ஸோ மெயினாக சேலஞ்ச் வந்து இப்போ நம்ம டேட்டா நீங்கள் ட்ரான்ஸ்மிட் பண்ணுறீங்க. என்னோட டிஜிட்டல் ட்வின் நான் வேறு ஏதோ ஒரு ஊரில் வச்சுருக்கேன், அதுக்கு ஃபீடு வந்து இப்போ இந்தியாவிலேருந்து டேட்டா அனுப்புகிறேன்னு வச்சுக்கோங்க. ஸோ ஹவு டு என்ஷூர் தட் த டேட்டா இஸ் செக்யூர்லி ட்ரான்ஸ்மிட்டிங், nobody is tampering the data or nobody is accessing data, for example. So maybe அங்கே தான் இந்த டிஃப்ரெண்ட் என்கிரிப்ஷன், டேட்டா என்கிரிப்ஷன் ப்ரோட்டோகால்ஸ் வரும். இப்போ நீங்கள் ப்ரௌசரில் போய் HTTP அடிக்கிறது போல HTTPS அடிச்சிங்க செக்யூர் சொல்லுங்க இல்லையா, சிம்பிள் எக்ஸாம்பிள். So similarly, the different encryption protocols which will make sure that nobody is tampering the data on the way. And once data reach on, they will decrypt it again and then they can start using it. So உங்க கொஸ்டின் ஆன்சர் பண்ணுறதுக்கு வந்து டிஜிட்டல் ட்வினுக்கு தனியாக ஸ்பெஷல் ப்ரொடெக்ஷன் அப்படிங்கிற மாதிரி இல்லை. வாட் எவர் த ஜென்ரல் சைபர் செக்யூரிட்டியோ இல்லை ஜென்ரல் டேட்டா ப்ரொடெக்ஷன் மெக்கானிசமோ தட் இஸ் அப்ளிகபிள் ஹியர் as well. Yeah.
Okay, sir. Thank you so much.
Yeah, thank you. Yeah. Any other questions? இல்லை தமிழில் கொஸ்டின் கேட்கலாம், பிரச்சனை இல்லை.
Sir, I'm Mahanand Kumar from third year mechanical.
Okay, hello.
Sir, how exactly does digital twin monitors in the earlier when you're talking about applications, I noticed that they said something about monitors a fleet of cars or something. How exactly does it monitor, and how monitoring using digital twin helps in maintenance?
Okay, exactly. Yeah. So how it monitors through the different sensors தான் வச்சுங்களேன். மேபி இப்போ கார்லாம் பார்த்தீங்கன்னா, இப்போ புதுசாக வர கார்லாம் பார்த்தீங்கன்னா அந்த என்டர்டைன்மெண்ட் சிஸ்டம் மாதிரி இன்ஃபோடைன்மெண்ட் சிஸ்டம் சொல்கிறாங்க. இப்போ காரில் வந்து மேபி ஒரு எக்ஸாம்பிள் வந்து இப்போ உங்களோட பிரேக் ஃப்ளூயிட் எவ்வளோ இருக்குது, இல்லை உங்களோட டயர் ப்ரெஷர் எவ்வளோ இருக்குது ஃபார் எக்ஸாம்பிள். இப்போ இந்த டிஃப்ரெண்ட் இன்ஃபர்மேஷன் இப்போதைக்கு என்ன பண்ணால் காரோட டேஷ்போர்டில் வந்து ப்ரெசென்ட் பண்ணுற மாதிரி வருது இல்லையா. காரில் ஒரு எம்பெடட் சிஸ்டம்ஸ் இருக்குது. ஸோ காரோட டேஷ்போர்டில் என்டையர் வெஹிக்கிளோட கண்டிஷன் வந்து உங்களுக்கு பார்க்க முடியுது. இப்போ நெக்ஸ்ட் ஸ்டேஜ் வந்து இப்போ உங்கள் கார் வந்து லெட்ஸ் சே இட்ஸ் ஹோண்டா காரோ இல்லை டாடா காரோ, ஹோர் மைட் பி த கார். இப்போ கார் மேனுஃபேக்சர் இருக்காங்கன்னு வச்சுக்கோங்க. இப்போ உங்கள் காரில் நீங்கள் அவங்ககிட்ட தான் நீங்கள் சர்வீஸ் பண்ணுறீங்க அப்படின்னா உங்களோட கன்சென்ட்டோ இல்லை உங்களோட அப்ரூவலோட தே கேன் கெட் யுவர் டேட்டா த்ரூ வயர்லெஸ் மெக்கானிசமோ த்ரூ த நெட்வொர்க்ஸ் வந்து தே கேன் அக்சஸ் யுவர் டேட்டா. ஸோ தட் மீன்ஸ் நீங்கள் அனுமதி கொடுத்தீங்க அப்படின்னா உங்களோட டேட்டா அவங்களால எப்பவும் பார்க்க முடியும். நீங்கள் வேணான்னு சொன்னீங்கன்னா யூ கேன் ஸ்டாப் இட். பட் இஃப் யூ ஆர் ஓகே தே கேன், நீங்கள் கிராண்ட் பண்ணீங்கன்னா அவங்களால டேட்டா பார்க்க முடியும். ஈவன் இப்போ சில கார்லாம் என்ன, இப்போ எமர்ஜென்சி சிஸ்டம் வந்து இப்போ நீங்கள் வண்டி ஓட்டிட்டு இருக்கீங்க, வண்டியில் திரும்பி ஒரு எமர்ஜென்சியில் வண்டி பிரேக் டவுன் ஆயிடுச்சு அப்படின்னா நீங்கள் அதில் ஒரு ஸ்பெஷல் பட்டனை கிளிக் பண்ணீங்கன்னா அந்த வண்டியோட இவங்களுக்கே வந்து இமீடியட்டாக வண்டி பிரேக் டவுன் இருக்குது அப்படின்னு சொல்லிட்டு தே கேன் சென்ட் தேர் சர்வீஸ் பீப்புள்னு வச்சுங்களேன். ஸோ அந்த மானிட்டரிங் வந்து த்ரூ த சென்சர்ஸ் தான். பட் அந்த சென்சர்ஸ் வர்ற டேட்டாவை அவங்க எப்படி யூஸ் பண்ணி அவங்களோட இந்த டிஜிட்டல் ட்வின் மாடலில் வந்து ஓகே இந்த கார் வந்து இவர் ஒழுங்காக டிரைவ் பண்ணுறாரு, பிரச்சனைலாம் போகுது அப்படின்னா இதுக்கு வந்து மெயின்டெனன்ஸ் ப்ராப்ளம் இல்லாமல் இருக்கும். இல்லை இவர் ரொம்ப ரேஷாக ஓட்டுறாரு, டெய்லி வந்து ஆல்வேஸ் 100 கிலோமீட்டர்ஸ்க்கு மேலே வண்டி ஓட்டுறாரு, அடிக்கடி பிரேக் போடுறாரு அப்படின்னா அந்த டேட்டா வச்சுட்டு ஓகே இவர் வந்து இவரோட காருக்கு வந்து சீக்கிரம் மெயின்டெனன்ஸ் பண்ணணும் அப்படிங்கிற அவுட்புட் வருது இல்லையா. ஸோ தட் இஸ் பேஸ்ட் ஆன் யுவர் ஓன் டிரைவிங் கண்டிஷனோ இல்லை யுவர் ஓன் டிரைவிங் ஹேபிட்டை வச்சு தான் தேர் அரைவிங் த டெசிஷன். அந்த டெசிஷன் அரைவ் பண்ணுறதுக்கு நம்ம மேனுவலாக பண்ணுறது போல அவங்க மேத்தமெட்டிக்கல் மாடல்ஸையோ இல்லை ஒரு இதை யூஸ் பண்ணுறாங்க.
Thank you.
Yeah, thank you.
Yes, sir. No more questions, sir.
Please go ahead. Yeah.
No, sir. No more questions, sir.
Oh, no more questions. Okay, sure. Okay, then. So thank you for your time. And ஒரு சாட்டர்டே மதியானம் நீங்க மற்ற வேலையெல்லாம் விட்டு இந்த டைம் ரொம்ப நன்றி. We'll catch up or connect again. Maybe college வந்தா I'll try to visit the mechanical department.
Sir, reunion நம்ம மே மந்த் சொல்லிருந்தீங்க சார்.
அந்த மே மந்த் அந்த இது இருக்கு அலுமினி மீட் இருக்கு மே 11th என்னமோ இருக்கு முடிஞ்சா I'll try to join.
Yes, sir.
ஏற்கனவே எங்களுக்கு மெசேஜ்லாம் அனுப்பிச்சிட்டு இருக்காங்க. So I will try to join.
Sure, sir.
Okay.
Sir, we need to thank you, sir. We are disturbing you frequently.
Okay. No problem. No issues. Yeah.
Yeah, your knowledge will be useful to the students, sir, because they didn't know about anything about digital twin technology. They discovered today only.
Oh, okay. Good. Okay. Sure. And if I know someone in my batch who are doing some advanced work or some other work on the digital twin, at least I'll refer them. Yeah. Okay. Yeah.
Okay, sir.
Okay. Thank you, Vignesh, and thank you all students, and have a good day. Yeah. Okay. Thank you. Bye.
Thank you, sir. Bye, sir.
Thank you.